Hello, my name is Georgia Warren and this is my solution to bonus problem 2. I have started solving the problem by drawing a diagram of the situation, including the two blocks and the directions in which they will accelerate, noting that mass 2 has a greater mass than mass 1. Other conditions to note in solving the problem include that there is no friction, that gravity is the same as gravity on Earth, 9.8 meters per second squared, that the angles are fixed, and that the string is of a constant length L. In part A, we're trying to find an expression for the tension force. What we want to do is consider the tension force on mass 1 and on mass 2. So for mass 1, the tension force is opposing the force of gravity and also causing an acceleration, while for mass 2, the tension force is opposing gravity and then also causing an acceleration in the opposite direction to gravity. And so what I want to do with these two equations is find an equation for the acceleration, which is caused by the tension force, and then equate the two expressions for acceleration to be able to rearrange them to find an expression for the tension force. So here A is equal to T minus m1g sine alpha, all divided by m1. And for m2, acceleration is m2g sine beta minus t, all divided by m2. Equating these and rearranging, what we end up with is an expression for the tension force, which is m1 m2g in brackets sine alpha plus sine beta, and that is all over mass 1 plus mass 2. For question B, what we want to find is a condition that has to be satisfied when the blocks are at rest or in uniform motion, so when acceleration is 0. So what I want to do is use the acceleration equations that I've already come up with in finding the tension forces on each of the blocks, and I want to set those both to 0 and then equate the expression that I get for the tension forces for each of those. So the tension force acting on M1 will be the same as the tension force acting on M2, and the blocks will not move. They will not be accelerated in any direction, and they will undergo uniform motion or be at rest. So what I do for that is simply equate these equations for A to 0. For M1, we get tension force is equal to m1g sine alpha, and for M2, we get the tension force is equal to m2g sine beta. And we know that these tension forces have to be equal. So we simply equate m1g sine alpha to m2g sine beta, and that is the condition that needs to be fulfilled for the blocks to be at rest or undergoing uniform motion with an acceleration of 0.